So, you guys, today we are starting section 8-3 in behavior of sequences. And so this first one says, as with any function, what happens to the value of t sub n of a sequence as sequence t as n gets very large is called the end behavior. So in other words, the further and further, the more steps that you take in these sequences, what happens? Does it go to a certain number, or does it go on to infinity? Okay, it depends on the sequence. So for instance, look at this first one on the left. This one has a sequence of -4, -2, -4, -6, -8, -10. What kind of a function does that look like? Linear, okay? And since it's a linear function, what kind of a sequence is that called? There's two types of sequences we've looked at. Arithmetic, okay? Okay? So, no, just that part. So anyway, B sub, oh yeah, you're right. It does go down there. Arithmetic. I was going to add something to it, but I thought. Okay? The terms of the sequence B, what happens to them as you go further and further out? They decrease, and then we can say that they decrease without bound. Okay? C, this sequence right here, notice it's getting smaller and smaller, and in this case it's called a harmonic sequence. It's getting closer and closer to what value? 0. Okay? We say that the terms of the sequence C approach 0 as n increases, and that 0 is the limit of C sub n as n approaches infinity. Okay, and you could write that like this: limit n arrow infinity of C sub n.
How do you approach infinity?
Well, you're just as the further along you go, it's saying it's approaching a certain number. Okay, in this case, it's 0. Okay, so this is one function.
Does it say limit C n equals infinity?
Yeah, n as n, that's an arrow, approaches infinity, C sub n. Okay?
Wait, it says limit?
Limit of C sub n,
No, underneath that.
right here.
What does it say?
Lim,
What does that mean?
that's limit,
Okay.
shorthand for limit, as n, arrow, infinity. As n approaches infinity, C sub n. Okay? Now look, this particular one is one you're just going to remember. It always approaches what? 0. Okay? 1 over n always approaches 0. All right. Let's look back at the left side again. Because the terms b sub n do not approach a constant as n increases, the sequence does not have a limit as n approaches infinity, or the limit does not exist. So I'm back to talking about the left side, about the line. The limit does not exist on the left side, but on the right side it does. Okay? You can see that by looking at the graph. This doesn't ever merge to one number, but this one does. Okay? Okay? Further on, it says, a sequence that does not have a finite limit is said to diverge. Or be divergent.
Is that a movie?
Mm-hmm.
convergent?
Does not have a limit. Okay? The sequence that has a finite limit, L, is said to be convergent. Or to converge to L. Okay? And a constant sequence, and what they mean by a constant sequence is a sequence that's like 1, 1, 1, 1, dot, dot, dot. That is said to be also convergent. Okay, so we're going to ignore this activity part for right now. But we say n approaches infinity, we write it as this. N arrow sideways 8, which is infinity. Okay? This says the limit of a harmonic sequence property, which is 1 over n, is 0. And that's read like this. The limit, not on this one, it exists, of 1 over n, the harmonic sequence, as n approaches infinity, is 0. So there are some important rules that you guys need to know. For instance, right here we say the limit of some constant k as n approaches infinity is always k. So an example of that would be the limit of, say, 3 is 3. Yep, 3 is a constant. It doesn't have a variable attached to it. Okay? If we say the limit of some sequence a sub n plus k, the limit of that sequence plus k is what the limit's going to be. So for instance, if I say the limit of 1 over n plus 3, that's the same as saying the limit of 1 over n, which is what? What was that? We just said, what is 1 over n as you approach 0? It's 0, right? Plus the limit of 3, which is what? So it would be 0 plus 3, that's 3. Okay? So I'm just going to put on top of this was 0 plus 3, so you can see that. Okay? Now this one says the limit of a sub n minus k. If I did the same thing, if I have the limit of 1 over n minus 3, what would my limit be? Negative 3. Okay? If I have the limit of 1 over n times 3.
Wait, where did you get 1 over n from?
I'm just saying, for instance, we know that that is the limit as 0 because we already just said right here, the limit of 1 over n is 0.
So should we not write this in as maximum?
Yeah, what I'm doing is giving you an example of, instead of just saying a sub n, you could put any function right there. The limit of that function as it approaches 0. I'm using one that you know now. Okay? So what happens is that limit times 3 here is the same thing as saying 3 times 0, which is what? 0. This one's going to happen to be 0 too, also. Okay? And the last one is if I said the limit of 1 over n divided by 3, what's that going to be? Which happens to be 0 divided by 3, which is 0. Okay? So, look at this one right here. It says find L, the limit of W sub n when W sub n is 16 plus 1 over n. What would that be? Yep, because 16 plus 0.
But what if it doesn't equal 1 over n?
It would be another kind of limit, and we'll talk about that in a minute. Okay? Yeah.
For 5
0 divided by 3 is still 0. You just can't divide by a 0. Okay? Good question. All right, so let's go on. By knowing the limit of a harmonic sequence is 0, you can apply these properties. Okay, back to where we were. By knowing the limit of a harmonic sequence is 0, you can apply these properties to find the limits of sequences with a more complicated formula. You can use algebra to transform the expression into one that shows the relationship of 1 over n. So for instance, look at this one right here. Okay, I can rewrite that as this. Okay, if I want to find the limit of that entire formula right here, I can do this. Limit, and note that just because I'm not writing this doesn't mean it's not there. The n approaching infinity, it's always there. I'm just going to have you guys assume that, okay? But of 5n over n plus the limit of 1 over n. Well, what's 5n divided by n? 5. So the limit of 5, and what's the limit of 1 over n? 0. Yeah, it's 0, right? Okay, so this limit is just 5. You guys have any questions on that one?
Why did it become 5 and 5n over n?
Because it's both of these divided by n, right? 5n plus 1 divided by n is the same thing as saying 5n divided by 1 plus 1.
Why did 5n over n cancel?
Because, yeah, the n's cancel. I'm sorry. Yep. Good question. All right, continuing on, we have the sequence of -1, 1/2, -1/3, 1/4, -1/5. And that is represented by this formula here. And it's graphed like this. Notice it looks kind of like a sideways tornado. Okay? Kind of does, like a funnel, okay? That one is called an alternating harmonic sequence. Okay? This sequence still converges and has a limit of what? Yeah, 0. But it's approaching 0 from both directions, both from the top and from the bottom. All right, so there's some other rules you guys need to know. When corresponding terms of two convergent sequences are combined with one of the 4 basic operations, their limits are combined in the same way. Okay, just like what we saw, if you take the limit of one sequence plus the other sequence, it's the same thing as the limit of the first plus the limit of the second. Okay?
Just like distributing the limit.
Yeah, you're kind of distributing the limit. Exactly. Same with this one. The limit of a minus b is the same as the limit of a minus the limit of b. Same with multiplication. You're just distributing it. Exactly. Okay? It's a good way of saying it. So, let's look at this next one. We have two sequences. We have p sub n right here, and we have q sub n. And it says, first of all, find the limit of p sub n. Well, we just did that. That was the one up above. What was that limit? 5, right? Yep. And the next one says, find the limit of q sub n. So let's do that. We got limit of 3n plus 2 over n. Okay, and that's the same thing as saying the limit of 3n divided by n plus the limit of 2 divided by n. Well, this one, the n's cancel, right? So what is the limit of 3? 3. Okay, so this one you have 2 over n. So I could bring that out to say the limit of 2 over the limit Well, I want to write it this way. I think it'd be better. Hold on a second. Let's write it this way. The limit of 2 times the limit of 1 over n, because we know the limit of 1 over n. Yep, it's still 0, right? Because 1 over n is 0, and the limit of 2 is 2, so 2 times 0 is 0. So it'll be 3 plus 0 equals 3. Yes?
So anything over n is just 0?
Yep. Yep. This one is for this one right here. We did that earlier. Yeah.
Then for the next one, do we have to do like the limit of b sub n, or could we just do 5 times 3?
Exactly. So, good question. You're right. So the limit of p sub n times the of q sub n, it's the same thing as saying 5 times 3, which is 15.
So then, would you say the limit of 5 times the limit of 3 equals the limit of 15?
Yeah. Yep. Okay, so on this one, it says, first of all, find the limit of u sub n and find the limit of v sub n. What do you know about these two equations? What kind of function are they?
You can do the factoring. You can factor it out.
You could, but first of all, let's just talk about this. It's a quadratic, correct? And it does this. Does that have any limits involved? No.
No, what's a limit? Oh, is that
So it's got the, there is no limit.
No.
Yep.
The limit does not exist.
Okay? No limit, or the limit does not exist. All right? So in this case, it goes on to infinity. It doesn't approach a certain number. Whereas the other one we were looking at was 1 over n. Notice that it kind of came up to a horizontal asymptote. What we're talking about with limits is when you're looking at asymptotes. Okay? All right, so the second part, however, is a little bit different. We're going to look at the limit of 4n squared minus 1 over 8n squared plus 20n plus 5. Okay? One other thing I want you guys to know is that as 1 over n approaches 0, so does 1 over n squared. So one of the things you might want to write on the side somewhere is that the limit of 1 over n squared is also 0. Okay? So on this one, if I actually go through and divide each of these by n squared, and that's what you're going to do here. Notice that the n squareds cancel here, and I'm left with a 4. What is the limit of 1 over n squared? 0. So I have 4 minus 0 on top. Okay, notice that the n squareds cancel here, and so what am I left with a limit of here? 8. My n cancels, so I'm left with a 1n on the bottom. So what is that going to be? 20 over n. What's that limit? 0. And what's the limit of 5 over n squared? 0. Okay? So my question to you now is, what is my limit of 4 over 8? 1/2.
How can you cancel out 20 over n? Does that mean there's 20 ones and there's
Because 20,
20 n?
good question. How can I cancel the limit of 20 over n? That's the same thing as saying the limit of 20 times the limit of 1 over n. and 1 over n happens to be a 0, right?
Oh, and then you times that
Yep. That's why.
by
Okay? Do you guys have any questions? This is brand new for you guys. So if you have any questions, please ask. Yeah.